So the first thing we want to do whenever we're making one of these graphs is one to draw where the midline is and then where the top and the bottom lines go. And so the midline, remember, is determined by that +1. And so I'm going to start by drawing in my midline there at 1. Then I need to draw my top line and my bottom line. Now the top line and the bottom line start off one above and one below the midline. So I drew those in. Once we've drawn those 3 lines in, making this graph is going to basically be the same as making any of the other graphs that we've made. It's all about just getting to know where the top, the middle, and the bottom all are. So, where does cosine start? Does it start on the top, the middle, or the bottom? It starts on the top. And if you know that, you just go to the top line that you drew in, and you put the dot at the top there. Now I'm putting a little green box around it, not because you need to, although you certainly can if you want to, but just to try to help you remember where it started from, because that's going to be useful as we go forward. All right, from there, that first point was at the top. Where do we go from the top? Middle, then bottom, then middle, then top. We're just following the same pattern. And so every 90 degrees, I'm putting in another point from that pattern of top, middle, top, middle, bottom, middle. That gets me on the right side. What do I do on the left side? The same thing, where I'm going top, middle, bottom, middle, top, and so on. I just follow the exact same pattern, and then once I've drawn each of those points in, I can draw the curve, and we're done. Now, of course, we've seen graphs kind of like this before. Remember that the very first place you saw this wave type of graph was on wall map. Just on wall map, I wrote it as 4 wave of x. So let's bring us back to what we did back in that case. When I multiplied wave times 4, what did it do to my graph? It stretched it. It made us go up 4 times as far, and it made us go down 4 times as far. Basically, it was taking those points and dragging them outwards. That's basically what we're going to do here, except of course we're not on the computers, we're doing it on paper, so we have to be able to see a good strategy. My strategy is again to draw in those dotted lines. The first one is the midline. Where is the midline in this particular problem? Well, there's nothing added or subtracted on the end to change it. So it's at 0, yeah. So I'm going to go ahead and draw in the dotted line there at 0. Yeah, you usually have to make it extra dark there so you're able to see it actually on the axis, because the axis is pretty dark too. All right, then from there, now we're going to put in the top line and the bottom line. And remember, those are affected by our vertical stretch of the 4. Now, the mistake that some people make on this is they say, okay, well, normally it's at 1, and so I'm going to count up 4 from there, and so they put it up at 5, but that's not right. That's where we add or subtract something to it. This is multiplying. If I take 1 and multiply it by 4, that gives me an answer of 4. So literally, whatever this number is, that's how high and how low you're going. We gave this a fancy name yesterday. We called that number the amplitude. So you could also describe it in those. Basically, it means that from our midline, I count up 4, draw in the top. And then from my midline, I count down 4, draw in the bottom. Now remember the whole reason why we draw these 3 lines. Once I've drawn them, I've used the transformation. I now am making the plain old cosine graph that I always make. And cosine, of course, starts at the top. And so my very first point is going to go at the top. By having the line already drawn in, I can see quickly and easily where the top is. And then again from there, if that's the top, I still know the pattern, right? It goes top, middle, bottom, middle, top. We know that pattern, and so we're just going through and putting each of those points on those respective lines, so that we can just look at the line and tell that I got to be putting a point on. I follow the same pattern as I head to the left. And so if I'm starting at the top, the next thing in the pattern is, of course, middle, bottom, middle, top. You notice that just knowing that pattern allows you to fill in so much of the graph. So I plot those points, and then once you plotted those, you're drawing in your curve. Now this one's a little bit taller than ones we've hand drawn so far. Make sure that you're drawing it as a curve. This is where it can be really tempting to make your graph come out looking like this. But that's not right. Remember, it's flattening out at the top and flattening out at the bottom. It's at its steepest when it crosses the middle. So this is then about how your graph should come out looking. All right, so we're graphing y equals a negative cosine of x here. The negative, again, we saw what happened with the negative before when we did the wave function. When we saw the wave function before, I'd give you the original graph and then have you graph the negative one. The negative one was the same thing but upside down, because when we have a negative out front, it flips it upside down, reflects it across the x-axis. Another way to describe it with this that works out nicely is that up becomes down and down becomes up. Notice in nowhere in there does that change the midline or my amplitude, just because I have the negative there. So my midline is still at 0. And I'm not stretching it outward at all, so I'm still going up 1 and down 1. The only real difference that we have to worry about is how we get to that first point. And remember, my first point's normally up at the top here. Well, I need to flip that upside down. Up becomes down. And so my first point is going to be on the bottom. And so once I've plotted that point on the bottom, I now know where to go from there because I know that pattern. After bottom is always middle, and then top, then middle, then bottom. And so we're just jumping into the pattern once again. By knowing the pattern, you know where to go from there, both on the right and on the left. And then once you plot the points, of course, draw the curve through it. If you get a chance here, compare this to the earlier graphs we made, and you'll notice it's the same graph except it's upside down. All right, so for this one, we have, again, a different transformation. In this case, we have the minus 90 inside with x. Well, anytime we add or subtract, it is always shifting it. If I add or subtract in with x, it shifts it in the x direction. Which way does minus move it? Is that to the left or to the right? Yep, it is to the right. Nice. And so what that means is that I'm going to be making the exact same graph as my parent function, except it's all going to be shifted over to the right 90. Now you notice what that doesn't change then. That doesn't change the midline. So my midline's still going to be at 0. That doesn't change how far up or down I'm going. And so I'm still going to go up 1 and down 1. But then the question is, where do we put our first point? Remember, normally I'm putting my first point there at the top on the axis. But this point, remember, is going to be moving to the right 90 degrees because every point is moving to the right by 90. And so my first point is at the top at 90 because I moved that first point right 90. Now, every single point does move right 90, but I don't have to move them all individually. I don't have to say, normally at 90, it's in the middle, and so I'm going to move that one over. You don't have to do that because we know the pattern of the graph. If this point is the top, where does the next one need to go? Middle. And if I go top, middle, what comes next? Bottom. And then middle. And so once you plot that first point, you know where to go from there, just because you know the pattern. And of course, it's the same thing here. Even though I started over at 90, it's the same thing as we go to the left. I'm just following the pattern. And so if this is top, the next one to the left has to be middle, and then bottom, and so on. And so we can get all the points on the left side as well, and then draw your curve through it. One thing that I would suggest that maybe you note on your graph though, you notice in my picture that I have here, I put that little box around the first point. You might want to, just for your own sake, on this graph, maybe put an arrow like that to that first point or something like that, just to help you remember that the first point was over there. That way, if you look back at this later, you can easily tell, how did I start it? What did that minus 90 do? Because you can tell, okay, I started over to the right 90. And it's just a way of taking notes to yourself that helps you remember and look at these. And all those little things now, when we put them all together, those little hints that we've been talking about can help when the complexity of an equation goes way up. But it still means that we can do these just as easily. So, write down this equation, and then after you've written down the equation, please draw in your 3 dotted lines. But don't worry about the points yet. That way, if there's a mistake in the lines, we'll be able to make the fix there. All right, so as you're looking at this, certainly the equation looks like, whoa, it's very complex. There's a ton of stuff going on. But notice we already know what each of the individual changes are. Like, what's this minus due to my graph? It flips it upside down. Remember, we did a negative cosine earlier. What does the 4 do to my graph? Stretches it, right? It makes it 4 times as tall, both directions. That's my amplitude. The minus 90. Well, we just did that one, right? We know that's going to move the whole thing right 90. And the plus 1 hanging on the end? Well, that was actually the first graph we did today, right? Or just moved the graph up 1. So we already know all of them. Now it's just a matter of seeing how we can pull them all together into one big picture. And this is where it is so important that you actually draw in those 3 dotted lines. Because if you don't, you're trying to keep track of all 4 of these changes in your head as you go, and almost always something falls apart. But if we draw in those dotted lines, you'll find we make our lives so much easier. Like, first thing we need to do is know where the midline is. Well, which number, which one of those, because only one of them, changes the midline?
-4.
It's the 1. Remember that the very first graph we did today, as well as actually the ones we did yesterday, they moved up and down. That's what the midline does, is that's where it's been moved up or down along the way. So your very first thing you're going to draw your midline there at 1. Then once we have the midline, we just need to know now, how far up and down am I going to be going when I plot my points? That's our amplitude, to use the fancy mathematical term. Which number determines how far up and down we go?
-4.
Yep, that's this one right here. Because remember, when we graphed 4 times cosine of x earlier, that's the one that made it go up and down further. Now, in this case, I'm not worrying about the negative part of that because, of course, whether I go up 4 or down 4, it's the same distance. So I count up 4 from the midline, and I put in the top line here. Then I count down 4 from the midline, and I draw in my bottom line. Make sure you have all 3 of those in the right place. All right, now having done that much, what I want you to see is that we've actually simplified the equation we have to worry about right now, because I just dealt with this plus 1 because I drew in the midline. So I don't actually need to worry about that anymore. Now don't cross it out in your equation because I want you to be able to look back at your equation and tell. But I'm removing it visually here just to help you see how we're focusing. And we've also dealt with the 4. So notice what's left. We only have 2 things left to deal with. The negative and the minus 90. That's all. Those 2 things together are going to tell me where my first point goes. So, to get to my first point, normally I put my first point at the top. What is the negative going to do to that point? It flips it, right? So instead of starting at the top, I'm going to start at the bottom. Okay, so then that's going to be telling me I'm going to be starting down here then. But of course, there is one other thing that we need to do to that, right? The minus 90. That moves it over. Specifically, just like we saw before, it moves it to the right 90. So I'm going to take that point now and move it to the right 90. then that right there is my first point. And so, make sure you have that point plotted correctly.
But that's not the ultimate.
Because if you have that one point plotted correctly, do you know where to put the rest now?
Yeah.
I hope so, because we know that point's at the bottom. And we have lines drawn for where everything else goes.
Yeah.
So plot the rest of the points.